today's lecture, we will understand how to write loops in C programming. As we know, in any programming language, when we write a program, all the statement will be executed sequentially. But if we want to repeat the execution of some set of statements, then we can use loops for that, right? So in any programming language, loops are used to repeat a block of code until a specified condition is met. There are three loops in C programming, right? For loop, while loop, and do while loop. So these are three loops in C programming, which we will understand in today's lecture, right? So these three loops are basically categorized in two types. Now, what are these two types? So the first two belongs to the category of entry control loop. For and while, both loops belongs to the category of entry control loop. Now, what do you mean by entry control loop? When compiler's control enters in a loop, at that time, if the prescribed loop is checking the condition, it means it is entry control loop. So at the time of entry, we'll check the condition. And whereas this loop, do while loop, checks the condition at the time of exit from the loop. It means what? The loop will run once without checking a condition, and after execution of all the statements inside the loop, it will check the condition, and if condition is true, then the loop statement will be repeated. Now, when we go in deep about in these loop, then we will understand how these loop will work. Okay. So first of all, we will start with the for loop. So the for loop is the easiest loop because all the condition, initialization and updation statements are bounded in a single bracket. So for the for loop syntax, what we will write here? We'll write the keyword for, and then the initialization statement, and then the text expression, and then the update statement. Now, for every loop, we are having a counter. Let's suppose I is a counter here. Here we can see this I is a counter. It is a counter for the loop. So, for example, we are taking I as a counter, and then we are applying loop here. So, we are starting I with 1. It means what? Initialization of I is with 1. So, this is the lower bound of the loop, right? And after semicolon, we will write I less than 11. So, this is what? Condition for now. We are writing a condition I should be less than 11. Then only, if it is true, then only loop statement will be executed, otherwise not, right? So, and the third statement is the updation of the counter. So, what is the counter here? I. So, we'll update it. We can increase or decrease the counter as per the requirement, as per the logic. Okay. So, what we need to understand? We need to understand when we write a loop, we write this for keyword here, and in small bracket, we need to write three things. First is the initialization of the counter, and then second statement is the text expression. If this expression is true, then only loop statement will be executed. The statements which are associated with the loop will be executed, right? And the third statement is the updation of the counter, right? All these three statements are separated with semicolon. No other special characters allowed here. No comma, nothing else. We need to write these all three statements with the separation of semicolon, right? So here is the simple example for a for loop. If we want to print the numbers from 1 to 10, then we need to write the loop which will start the counter with 1, and counter should be less than equal to 10, or we can say counter should be less than 11, which we have written here. So both are true. And we need to print 1 to 10. We require this output. We need to print numbers from 1 to 10. So inside the loop, what statement is written? Printf. Okay. So what this statement? Printf I. So I, value of I will be printed. So first of all, how this loop will be executed? First of all, compiler's control will come here. This header file will be included. Then the main function will be executed, and then will come here and I will be declared, and then loop will be started. I will be initialized with 1. So this initialization begin with 1, and then condition will be checked. I is equal to 1. So this condition is true here. Then compiler's control will come here inside the loop. Inside the loop, in curly braces, we are having a single statement, because in this program we need to print number from 1 to 10. Okay. So in this printf statement, what is happening? Value of I is printed on the screen. Value of I this time is 1. So 1 will be printed. And then no other statement is associated with the for loop. So counter will be updated for the next iteration. So in the first iteration, we get the answer 1, and then I will be updated. Now I is, what do you mean by this plus plus I? It means I is equal to I plus 1. It means what? I was 1 in previous iteration. Now I is 2 in this iteration, right? And then again condition will be checked. Condition is true again. So the next value, current value of I will be printed again. So this is what? 2. No other statement is associated in this loop. So counter will be increased in the next iteration. So this is the third iteration basically, right? Then condition will be checked. Condition is true. Then it means what? 3 will be printed. Then counter will be updated. Condition is checked. This statement is executed. Counter is updated, condition is checked, statement is executed. When this condition is false, then only will come outside the loop. Compiler's control will come outside the loop when this condition is false. So when this condition will be false, if I equal to 10, then also this condition is true. So condition will be false when I is equal to 11. It means what? I is not less than 11. So condition will be false this time. So by this way 1 to 10 will be printed on the screen. Fine. And this is the flow chart for the loop. Sometimes in some examination, flow chart for a particular loop will be asked. Then you can make such flow chart. This is what the initialization of the expression. Initialization expression means initialization of the counter, loop counter. Then the condition is checked. All the conditions are checked on the counter only. If it is false, loop body will not be executed, and compiler's control will come outside the loop body, right? If this text expression we are checking on the counter is true, then the statement associated with loop body will be executed. If it is single, we can write without the curly braces. If multiple statements are associated with loop body, then we should write with inside the curly braces. Okay. And then updation expression. It means loop counter will be updated for the next iteration, and then condition is checked again. And then if condition is true, then the next iteration will be executed, then counter will be updated, and so on, until this expression becomes false. So by this way, we can execute the same set of statement repeatedly until condition is going false. Now, this is the proper example of the for loop. In this loop, in this example, we need to print the Fibonacci series. Now, what is the Fibonacci series? In the Fibonacci series, first two terms are 0 and 1, and the next term is the sum of previous two terms. So, it is again 1, and the next term is the sum of these previous two terms. So, this is 2, And then again, next term is the sum of previous two terms, that is 3. Next term is the sum of previous two terms, that is 5, and so on. So like this is the Fibonacci series. We need to print this Fibonacci series through the C programming, right? So for this, what we need to take, when we start a program, we need to write a loop counter, that is I we are taking here. Now, how many terms we want to print? So we need to take a variable for that, and the first two term, first term is 0 and second term is 1. So we are taking two variable T1 and T2 to store the term 1 and term 2. And this is the next term which we need to calculate by sum of previous two terms. Okay. Then we are allowing user to enter n. N means number of terms which we want to print for the Fibonacci series. Let's suppose user is telling n is equal to 5, right? So this loop will be executed, loop will run for 5 times, because we need to execute, we need to write 5 terms, we need to print 5 terms on the screen. So we will start I is equal to 1, will initialize I is equal to 1. So the first term will be printed when I will be 2, second term will be printed when I will be 3, because we are updating I every time after every iteration. So by this way we can print till 5. So we need to put condition here, what? I should be less than equal to n. N is 5 here. So I will go to the 5. I equal to 1, 2, 3, 4, 5. And after that, this condition will go false. It means what? Loop will not be executed. So this loop will be executed 5 times. How this loop will be executed? I is equal to 1. Condition is true. Then we'll come inside the loop and we'll print this T1. T1 is the first term. So what will be printed on the screen? That 0 will be printed on the screen, right? And then the next term will be calculated. So next term will be the sum of the previous two terms, means T1 and T2. Okay. So the next term is 0 plus 1. It means what? 1. Now T2 is assigned in T1. Now what is in the T1? 1, because 1 was in the T2. And then the next term will be assigned in T2, because we are taking only 2 variables and we are using those 2 variables for the next terms, right? So now what is happening? We are making this assignment. After this assignment, there is no another statement. So compiler control will come here on the updation and I will be updated. Now I is equal to 2 and we'll check the condition. Condition is true, and then we need to print T1 again. What is now in T1? T2's value is assigned in the previous iteration in T1. So that value will be printed. That is what? 1. And then again, next term, T1, T2, all are updated, right? So now this time, as T1 and T2 was what? T1 was carrying 1 and T2 was carrying 1. Both were carrying 1. Okay. So next, when I is equal to 2, I is equal to 3, it means what? Third term. Condition is true, and then T1 is printed. So now this time in T1, what is in T1? 1. So this will be printed, and then all the terms will be updated now. By this way, we can print 2, 3 till 5 terms on the screen. So this is the output for the Fibonacci series we get from this program. Now the next category of loop is the while loop. In the for loop, what we can see, we are checking the condition when we are entering in the loop. It means what? It is entry control loop. We are checking the condition at the time of entry in the loop. Similarly, in the while loop, it is also entry control loop. Here we can see we are writing this keyword while, and with the while we are checking the condition. It means what? Condition we are checking at the time of entry in the loop. It means what? It is the entry control loop. Now what is the syntax? What is the flow chart for the while loop? We can see, first we can see the flow chart. We'll check the condition. If this condition is true, compiler's control will come inside the body and statement inside the body will be executed. And then for the next iteration, we'll check the condition after updation of the counter. If condition is false, then compiler's control will come out of the loop body. Right. Now, what is the syntax for the while loop? What is the syntax? We need to write while keyword, and then in small parentheses, we need to write text expression. This text expression will be written on the counter, loop counter. And then inside the loop, as a last statement, we will update the counter for next iteration, right? So here again we are taking a small example. We need to print from 1 to 10 on the screen. How to write the while loop for that? Similarly, in the previous example, we have initialized I with 1, but in case of for loop, we will write the initialization, text expression, updation all together in a single parenthesis. But here with the while loop, we are initializing the counter here. Initialization of the counter, and then we can write the text expression on the counter with the while keyword. And the updation of the counter is here. Updation of counter. Here as a last statement of the loop body. For the next iteration, it is updated. So here initialization is the outside of the loop. So once it will executed, and then the text expression will be checked. I equal to 1, which is less than 11. So the condition is true. Compiler's control will come inside the loop and printf statement will be executed. Then 1 is printed here because I is carrying 1 that at this time, right? Then counter will be updated, means I will be now 2. Then compiler's control will come here again on the text expression, and the text expression is checked. So this expression is true again for the next value of I. So the compiler's control come here again inside the loop, and I will be printed again, that is 2. So 2 is printed on the screen, and for the next iteration I will be updated. So I is 3 this time, condition is true, I will be printed, that is 3, and then counter is updated, and so on. When counter goes false, when this condition goes false, when I equal to 11. If I equal to 11, this condition goes false. Before that, we have printed till 10 on the screen. We don't want to print this 11. So at this 11, we are making the condition false, and then compiler's control will come outside the loop and nothing will be printed after 10. So this is how while loop will work. We can take an example of the while loop. Here is the program to reverse a number. If we are having n is a variable, we are having 256 this time in this number. So now I need to reverse this number. It means we need to get 652 from C program. How we write C program? For this, we will take a variable n, we will take a variable reverse in which we need to initialize with the 0 and then remainder. Because from this number, we will separate this digit. Okay, and then we will arrange here. Then in the next iteration, we will make this digit separate and we will arrange here. And in the next iteration, we will separate this digit and we will arrange here. Right. So by this way, it will work. So here we are taking n from the user. We are allowing user to enter n. So let's suppose n is 256. Now what logic we are applying here? We are applying while loop. Okay, this is the example of the while loop. So as we are picking this digit, then this digit, then this digit. Now after 2, this number is finished. So what we can write here? While n is not equal to 0. Okay. Or we can write n is greater than 0. It means what? When n becomes 0, then we need to stop the loop. If n is greater than 0 or n is not equal to 0, we need to run the loop. When we take out all the digits from this number, then this number will become 0. So we need not to run that loop, right? So we can write n is not equal to 0 or n is greater than 0. Both conditions will work here for reverse the number, right? Then we are having a variable remainder, and because we need to separate out this only this digit, so we will take the modulus with 10, right? And now what will come in the remainder? In remainder we'll get this 6, right? That will be assigned in remainder, right? And then this is the number, reverse number. We get the reverse number in REV variable. Now REV variable is 0 initially. So we are multiplying with 10 because we need to shift the digit every time. First we will get this, and when we will get the next digit 5, then we need to write this 5 means 65. So this 6 is shifted by the 10th place. Okay. So what we are doing here? REV is 0. That is multiplied by 10. It becomes 0 again, and then the remainder is 6. So in REV, we are getting 6 only in the first step. And then n divided by 10. It means n is updated by, n is this. It is divided by 10. It means what we are getting? 25.6. Because n is integer, so this part is not come in the integer, only integer part will carried in n. So n is 25 now. For the next iteration, n is 25 means what? N is not equal to 0. Condition is true again. Then will come inside the loop, compiler's control will come inside the loop, and then the again remainder will be calculated. Now this time n is what? 25. So if we are taking modulus with 10, so what digit we will get here? 5. So this time we are getting 5 in remainder. So in REV we are having 6. So 6 is multiplied by 10. It means 60 plus remainder this time 5. It means what we get? 65 in REV. Now n is updated. In the previous iteration n was 25. Now 25 is divided by 10. So what we will get? 2.5, but n is integer. So it will carry only 2. N is not equal to 0 because it is true. It will come inside the loop, and then 2 modulus 10. It means what? What is the remainder we get? 2 in remainder. And what is in the REV? 65 by the previous iteration. So now this time we'll multiply by and then 10. So we'll get this 650, and then in remainder we are having 2, right? So what we will get in REV? 652. And then n will be updated. N will be divided by 2. So this time we are having 2 in n. So if we are dividing this by this, so what we will get? 0.2. But it can carry only integer part, which is what? 0. So n becomes 0. So this condition is what? N should not be equal to 0. But n is equal to 0 this time. So this condition is false, and compiler's control will come here outside the loop, and REV will be printed, in which we are getting the reverse of the number. That is 652. So by this way we can reverse the number. Right. So again, next loop is the do while loop. This is the third loop. It is also known as exit control loop. Why it is known as exit control loop? Because condition will be checked at the time of exit from the loop, not at the time of entry. How it will work? We will simply write do. We are instructing the compiler do. Whatever written inside these curly braces will be executed as it is without checking any condition. After executing all the statement once, this while will be worked, and then text expression is checked. If this condition is false, then this loop statement will not be executed again, right? So by this way, while loop will work without checking any condition once, and if condition is false, it will not run again, right? So sometimes while loop will be used for the debugging purpose also, right? The same example we are taking here, like we need to print from 1 to 10. Okay, so what syntax we need to write? Again, here also we need to initialize the loop counter with 1 as previous, right? We need to write do, and in brackets, in curly braces, we need to write the loop statement. And now what is the loop statement? We need to print this value of I, right? So we write printf %d is the format specifier for integer and then I. So I will be printed. If condition, we are not checking basically condition, we are just initializing the loop, and then we are instructing to the compiler do, means print this. So 1 will be printed, right? And then counter is updated, means I will become 2. Now condition is checked. If this condition is true, then loop statement will be executed again. So I will be printed 2, and then I will be increased, then condition is checked, and then I will be printed again 3, and so on. When this loop condition will be false, when I will become 11, then this loop condition will become false, right? Now, what is the difference between the while and do while loop? Basically, if instead of 1, we will initialize this I with 100, right? Now, we need to print this 1 from 1 to 10. But if by mistaken, we initialize this I with 100, then what will happen? We are instructing the compiler do, means I will be printed. Whatever value of I, irrespective to this, I will be printed. So what we are getting on the screen, 100, right? And then condition will be checked after updation of the counter, right? Then this condition will become false. So next time loop will not be executed. Here we can see, though condition is false, then also I will be, first value of I will be printed. So this is the difference between the while and do while loop, right? Now this is the example for the do while loop. In this example, we are basically calculating the palindrome. So this example, palindrome means what? It means if we are having a string or a number, and then that will be reversed, that number is reversed, and then also when the number is reversed, then it means what? If it is palindrome, it means we will get the same number. Like if we are having 1 to 1 and we will reverse this, then also we will get this 121. It means this is what? Palindrome, and this number is not palindrome, right? So what is happening here? We are entering a number, we are allowing user to enter a number, and that number is taken in another variable. Why we are taking that number in another variable? Because if we will not take that variable in another variable, then n will goes 0 at last, as previous example, right? So this is totally same as the previous example, as we have reversed the number. So this is same. So we are checking that number is palindrome or not. Means when we are reversing that number, that comes similar number or some different number, right? So this logic is same, and in this S, we are getting the reversed number, right? We are getting the reversed number, and the original number we have copied in A, right? So this is the same logic, I'm not explaining again. But at last, what we will check? We'll check if A is equal to. When we need to check the equality, then we need to write the twice that assignment operator. Then it will come equal to operator, right? So we will check if A is equal to S, because original number we have transferred in A, and the reverse number we get in this S. So we will check If it is equal, we can say this is the number is the palindrome. If it is not equal, it means we clearly say that number is not a palindrome number. So with the help of the same logic as in the previous example, we have checked the palindrome number also, right? So these are 3 loops. Again, in the next lecture, we will have more about the loops. Thank you so much.